Alright, so we're in Unit 2, and we're on Day 2, and this is going to be about determining functions. And so let me go ahead and show you that right there. So today, we got Unit 2, Lesson 2, and I forgot to put this up here. We're going to determine whether a relationship is a function. We're going to find function values, and we're also going to be able to find zeros of a function. A function is a relationship in which each element of the domain is paired with one element of the range. Hopefully you remember from Algebra 1 Part 1, domain is your x values and range is your y's. So each x has only one y. Okay? Different x's or different y's can have the same x. No, different x's can have the same y. Yeah. So, we don't want our x's to cheat. So, when I do this one over here, and I look at determine if it's a function or not, I'll list all the x values in order from least to greatest. So I have -1, 2, and -1. I don't list -1 again because it's already here. And then the y's, I can put them in whatever order. Doesn't matter. So -1 goes to 4, 2 goes to 3, -1 goes to -5. Let's check this one out over here. -3, 1, and 2. And I have 1 and 5. -3 goes to 5. 1 goes to 1. And 2 goes to 1. So now we have to determine which one of these is a function. Well, the only one that's a function is the one that doesn't have an x going to two different numbers. Well, -1 goes to two different numbers. And if you look in this list, -1 repeats. This is not a function. In this one, all three of the x's go to different numbers. So this one is a good function. Okay? You can look at these and tell whether or not they are functions just by looking at the list, either in a mapping or in a table or in a list. And the key is, does the x repeat? For number 1, is there an x that repeats? No. This is good. Number 2, is there an x that repeats? Yes, we have a 1 in here twice, so this is not a function. Number 3, is there an x value that repeats? Or number 4, I'm the numbered wrong. 1, 2, 3, -6, -3. No x's repeat. That is a function. Number 5, 6, 2, -4, 4, 2. We have an x that repeats, not a function. The reason why we check the x's is because a group of points or a line have to pass the vertical line test to determine whether or not they are a function. And so the rule is, if a vertical line can be drawn so that it intersects the graph at 2 or more points, then the relationship is not a function. So if I take my pen and go across these graphs, do I ever hit more than one point? Well, in the top two, the answer is no. I don't hit more than one point at any one time when I draw vertical lines through the points. I always just hit one point. So this is a function, and that's a function. But what happens here? I hit 2 points, not a function. What happens here with a vertical line? Well, I'm hitting a whole bunch of points, not a function. Okay? Sometimes you get a graph with a hole in it. So if you see an open circle on the graph, that means there's a hole in it. meaning that there's nothing there. So if you see a graph like this, I know you would say, well, wait a minute, there's 2 points. But is there really anything there? No. So then this is a function. However, what happens if I take basically the same graph and I add a point right here? Well, when you draw the line through, does it hit 2 points? Yes. So this is not a function. In our classwork today, we're going to focus on, or classwork tomorrow, we're going to focus on being able to identify functions, and that's half the battle. And so you guys have probably done pretty good with that, so I don't want to spend any more time on that. What I do want to spend time on today is function notation. When you see y is equal to 2x plus 1, and it tells you to find y if x is equal to 2, essentially we're saying substitution. So if you put 2 in for x, you guys know how to solve that. Function notation says the same thing, except for now we have this whole f of x. And so f of x replaces y, and that's literally the way we say it, because the relationship is a function of x. So if I tell you to find f of 2, all I'm saying is plug 2 in for x. So if we do that up here, if I tell you to find f of x equal to x plus 1, when find f of 2, you would say f of 2 is equal to 5. And you did that because 2 times 2 plus 1 is equal to 5. It's just another way to cover substitution. So I want you guys to try that using these 2 equations. You have f of x is equal to 3x minus 2. G of x is equal to x squared plus x. Go ahead and substitute the correct number into the correct places. Pause the video. Okay, so hopefully you were able to get the video paused and do those and have no problems there. Now, sometimes the functions will say to add 1. That's not a big deal. We're still following the same rules. We're still going to substitute 3 for x. But just when we're done doing that, we're going to add 1. So like, for example, if I have 3x minus 2, I'm going to plug 3 times 3 minus 2. But then when I'm also done with all that, I'm going to go plus 1. Okay? So 3 times 3 is 9, minus 2 plus 1. 9 minus 2 is 7, 7 plus 1 is 8. Also, if I went too fast up here, I'll let you pause so you can check your answers. I just realized I might have done that. So take a couple seconds and answer these questions and pause the video, and you guys will come back with the answers. Okay, so there's the answers for these 4 questions. Again, like I said, you're still doing the same thing. You're just doing the substitution and then doing something else. So hopefully you guys were able to get the right answers on that. Sometimes you won't always get a number as an answer. So if my function is f of x is 3x minus 2, and it tells me to plug in x minus 3, then what I'm going to do is where I have the x, I'm going to plug in x minus 3. So really, what property are they trying to get me to use here? They're trying to get me to use distributive property. And so I do 3x minus 9 minus 2, and then I simplify. 3x minus 11. 3 times x plus 1 minus 2. I'm going to let you distribute that and solve that one out. You're also going to distribute, you can distribute 2c, you can distribute 4b. I'm going to leave these 3 for us to go over in class to make sure you understand how to substitute in something that's not a number. The last thing that we're going to be focused on here is zeros of a function. Finding the zeros of a function means finding the values that cause the function to equal 0. So when you're asked to find a 0, see, here's the thing. We've done a substitution, and now we're going to find a 0. And so a lot of people like to put 0 in for x, and that's not what I'm asking you to do. What I'm telling you to do when I say find a 0 is set the function equal to 0, and solve for the variable. So if I tell you to find the 0 of 3x plus 9, you're going to take 3x plus 9 and set it equal to 0. So then 3x is equal to negative 9, x is equal to negative 3. That is a 0 of the function. And what ends up happening is that comes from the idea of when you look at a graph. So when I look at 3x plus 9, I'm going to put my calculator over here, get away from the glare. Oh, let me go to y equals 3x plus 9. When I look at the graph, where does the graph cross the x-axis at? Well, we got x equal to negative 3. Sure enough, that's where the graph crosses the x-axis. That's what it means when I say 0. So your last bit of homework is to do these three. Find the 0. Set the equation equal to 0 and solve. And we will go over these in class tomorrow.